Oh, now it's recording. Okay, let's go back. Okay, so are there any questions on naming these or getting the formulas for these types of compounds? Looks pretty straightforward, so let's do the following. You're going to give me the formulas for that's an E, by the way. Let me print that out. Okay, so I would like not the formulas, the names. Oops, I already gave you the formulas. So let's have you give me the names. Okay, so what would you call the first one? Okay, but what do we know about the zinc in particular? So you have your zinc, you have your fluoride, and zinc is a transition metal, but isn't that one of the exceptions? Ah, so zinc, when we have the ion, will +2. So we don't need to write the charge. Okay. What about the next one? And you guys can talk. It's just, I think Loretta had an ice machine in the background making noise, but if the ice machine isn't going on, she can say stuff too. I don't mind not talking to a black hole.
Yes, but she has customers coming in and out. So this might have not been the best idea, but a lot of this stuff I know it's gold and phosphorus.
All right. So what would you call the gold, the phosphorus anion? Right. This is an ionic compound. So gold, and it's not phosphorus, it's going to be what? Right. See how fluorine isn't fluorine, but it's fluoride. So instead of phosphorus, it's going to be phos. What does it need to end in?
Can't just be phosphide. I never heard of that one.
What is phosphide?
Oh, phosphide.
Uh-huh.
Okay. Well, all right. That's better.
That's perfect, Melissa. Now, unlike zinc, which is an exception, gold is a transition metal, and it doesn't have an exception. So what's the charge on my gold ion? We need to put that in here. Is it 3? 1. I swear, when you guys take exam 2, I should just have some button that you can hit like, are you sure? That's right. It is 1. Phosphide is a -3. And since I have 3 gold cations, it's got to be gold 1. What about the next one? Yes, beautiful. And since lithium is a main group metal, we do not have to write the charge. Lithium selenide. And last but never least, I hope you can see it still. What's this going to be called? No, manganese 3 oxide. Loretta, when you look at the, oops, I forgot my E here. When you look at manganese, this is a transition metal, and that's why charge is in. That's perfect. Okay, manganese 3 oxide. All right, so that's why you need the charge. Okay, all right. You guys have this down. So let's look at molecular compounds. And the only ones we're going to do are what we call binary molecular compounds. That means 2 elements only. Okay, so what you're going to do is you're going to have a prefix if you have more than 1. Otherwise, you don't include your prefix. Okay, plus the first element name. And then you have a space, and then you're going to have the base. Hold on, you're going to have your prefix plus the base of your second element. And then you're going to end in I. Okay, so we'll finish your molecular binary compounds, and then we'll go on to polyatomics and then go to acids. Okay, so what are these prefixes? So the prefixes are to represent your numbers. How many? So what are they? Mono is for 1. Okay. Di is for 2. Tri is for 3. Tetra is for 4. Penta is for 5. Hexa for 6. Hepta 7. Octa 8. Nona is 9. And deca is 10. Okay, can you go higher than 10? Yes, you can. It's undeca and dodeca, but normally you're not going to see a lot higher than 10. Okay, so keeping this naming rule in mind, then how would you name this compound?
Is it carbon oxide?
Oh, let me ask you this. It's carbon and there's an oxide. Is that Jose?
Yes, it is.
Hi, Jose. How
Hello.
many oxygens do I have?
You have 2.
So is that
It's
oxide or what do you
carbon
mean?
dioxide?
Yes. Are you guys making this more difficult than, if I said carbon dioxide, what's the formula? Wouldn't you tell me CO2? You probably wouldn't think about it,
Yes.
right? I just thought I'd throw that out just to see if you guys are gonna, like, make life difficult for yourselves.
So you actually want me to think less?
No, well, it's kind of like, what did my music teacher used to say? He goes, Charlie Parker used to say that you want to, like, when you're studying, you want to work really hard and spend the hours. Like, they always talk about the 10,000 hours. But then when you're out on the stage, you just let the beep, beep, beep fly, right? In other words, I want you to think really hard now, but then at some point, you're just going to have to let go and just do it, right? You guys are like, really? Yeah, you got to trust
Trust in
yourself.
myself.
That's right. Okay, so what happens if, so let's take a look. Carbon, I only have one, so I do not need a prefix. So I just give the first element name. I have 2 oxygens, so the prefix for 2 is di. The base of my second element is ox, and then I end in I. So how do I know that I'm not following the ionic compound naming? Because I end in I here, just like your ionic compounds. One, you don't use these types of prefixes. You don't use mono di in your ionic compounds. 2, look, non-metal, non-metal. And when you look at your ionic compounds, they are what? Non-metal, non-metal? What are they for ionic compounds? Metal, non-metal, right? So that's part of how you can tell the difference, because now what we're doing is, depending upon the substance, you're going to have a different rule, and you've got to know what your substance is before you know what rule to follow. Okay, so let's do another one. You're going to do okay, so how would you name the first one? Do I need to use a prefix, or do I only have one? Diphosphorus pentoxide. Yes. Diphosphorus. And sometimes what you'll see us do, we'll actually drop one of the vowels. So instead of saying oxide, we'll just say pentoxide. Okay, just because it sounds better. But if you write I know, right? If you leave it like that, I'll take it, because sometimes we'll drop it and sometimes we won't. So how will you know? And just because it looks like it's English doesn't mean it's going to sound like when you're reading out loud a really nice novel. It'll require a lot of stumbling. Diphosphorus pentoxide. That's perfect. All right. How will we name the second one? Well, I think it is a gas, so it is levitating. And you thought I did. Oh, follow naming rules. We're not going to use nitrous, right? It's going to be what? What's my prefix? What's my prefix for the now I only have an oxygen, right? So don't I need a prefix for that? Nitrous oxide. Yes, yes. But dinitrogen, and instead of oxide, what's my prefix for one?
Mono.
Mono. I know, don't contract it though, right? Just kidding, just kidding.
Monoxide. Okay.
Monoxide. So dinitrogen monoxide. Now, if you look it up, you'll see a whole bunch of different names because we have common names and we drop things all the time. But the bottom line is I want you to follow these, the rules, the systematic naming rules. So it'd be dinitrogen monoxide. Okay. So what about this one? Well, I always say, you have to break the rules to make the rules. So we do have a lot of exceptions. Yes, we're very consistent in the consistency. All right. What would you name your last one in this column?
Carbon monoxide.
Absolutely, Jose. See, that didn't give you any trouble. Just carbon monoxide, but that's why we name it carbon monoxide. It's coming from our naming rules. Okay, you guys, one more column and then we'll move on to polyatomic ions. Okay, and because Loretta, for the first element, if you only have one, we don't use a prefix, which is why we don't use mono we don't say mono carbon monoxide, we just call it carbon monoxide. So when you have two or more.
I thought that was funny, but I even left out the first O, so the mono. So it wasn't end up funny anyway.
No, well, that's okay. We have these rules and we break them so often. So people give me all these different names. It's like, yeah, I know, but the naming rule says first element name, if you have one, then there's no prefix. It's two or more, then you use the prefixes. It's the second element that we always use the prefixes. That's okay. This is why I'm doing this. I'm just randomly throwing stuff at you and having you name it. So name SO2 for me, please. Sulfur dioxide. Okay. Perfect. All right. And what would you name F2? You sure? How does fluorine appear?
It's fluoride.
No, it's not even fluoride. It's
No.
not an ion, right?
Oh,
This is just your element.
I'll just mute.
No, you don't have the mute. You're just going to use your element name, just fluorine. Of course, my writing's hard to read. Let me just for you. Just fluorine. Okay, because I threw in there an element just to see if I can catch you off guard. Right, because fluorine is one of our diatomic molecular elements. It's the have no fear. It's the fear part. Yeah, it was the fear that got. Okay, we're getting close to Halloween, so I don't blame you. Okay, what about the last one? Iodine. Is it pentabromine? How do we end the second element? Iodine pentabromide. Perfect. Okay. Great. You guys are doing fantastic. Yeah, that's what I said. Okay, so now you know how to name ionic compounds. If I just have basically a monatomic metal cation, and I have my monatomic anion, and you know how to name molecular compounds, binary one, so only 2 elements. And then last time I gave you this sheet, and I think it looked like, hold on, where'd it go? This one. Okay, this, I put this in the chat box, right? So everyone had a chance to download that file, or not yet? Yes, did everyone get a chance to download this file? Okay, good. If you have an issue, then let me know. Or maybe what I'll just do is I'll just post it up in the module. Okay, now this list actually originated from the 120 list. So getting a head start is good for you anyway. This is good. Now, when we say the list of ions to learn, like in table 1, the ions with a fixed charge, you know you're going to see this before, because remember, you're going to look at the periodic table and you're going to say, oh, look at this. I know these because these are on my periodic table and they're all the nonmetals, right? And then you look at your group numbers, sulfurs and 6. So what's 6 minus 8? Minus 2. Oh, look, it's got a charge of minus 2. And then when you look at your metal cations, the main group, right? You're going to look at, oh, lithium is in 1A. So the charge is a +1 for the ion. Okay. So all of these you can look up. All right. Okay. Even these guys. So on here, what do you need to be aware? I'm not going to give you much bismuth. Okay. For 122, when you take general chemistry 2, for one of the labs, we have bismuth in there. It's a heavy metal. It's not good for you. Please do not eat it. Okay. Now, the one thing though, notice for hydrogen, remember we always talk about how hydrogen is pretty unique. So hydrogen ion, see that naming? It's the name of my element, and then I add ion to the end. That means it's a positive charge, so it's H+. If I end in "ide," that means it's an anion. So hydrogen ion is H+, hydride ion is H-. Just be aware of the naming, okay? That's just following our naming convention. And hydrogen's unique because it can be both a positive, that's usually what we see, or a negative, which is highly reactive, but we can get it anyway. All right. Now, that's why when I look at this one, you should know it, but you can get it off of the periodic table. All right. The variable charges. So remember mercury 1, or if I didn't tell you last time, I'm telling you now. mercury 1 is unique because mercury 1 has 2 mercury atoms, 2 plus. So why do we call it mercury 1 if it's got a total charge of 2 plus? Each mercury atom has a +1 charge. So mercury 1, each mercury atom has a +1 charge, but the mercury 1 always shows up as a complex of 2 mercury atoms. Everything else in my list here, okay, they're just the single metal cations. So what you're going to do, you're going to look and you say, oh, they're transition metals, and you're going to have to figure out what the charge is. Okay, if you have a formula and you have to name it, and that's why the anions are so important. Okay, now what? You don't need to know the common name. Like I mentioned before, common name only tells you ferrous has a lower charge than ferric. Doesn't tell you what it is. Okay. But now the symbols for your polyatomic ions, you're going to have to memorize. And yes, please memorize it. Every day you're going to memorize another 2. Okay. So out of this list, which do you have to memorize? Well, let me tell you. All of these. All of these. And you may also see periodate, iodate, hypoiodite. You might also see O2 minus, which is iodite, bromate, hypobromate. You'll see bromite, you'll see BrO2 minus bromite. Okay. And then you can have perbromate. Okay. So those are all important. Memorize them. Okay. And then what about these guys? All the way down. I'm going to ask you about arsenate, selenate. I'll leave the last 3 on this first column. You must know this one. This is a biggie. Acetate's really important. So you can leave 3 for 120 here. And then you should know these guys. I probably won't ask you too much about borate or tetraborate. Although if you use borax in your laundry, then you'll probably want to know what your borate looks like. And definitely you'll want to know this one, ammonium. That's a big one. Okay. So I haven't made you memorize everything of this whole list that I gave you for your polyatomic ions. You don't need to memorize 5. Okay. So that's really good. Now, notice for the polyatomic ions that spans these 2 pages. All right. Almost all of them are anion. 1 is a cation. Okay. So what do we do with this? Let's go back. Take a look at this. Okay. So we've done our molecular compounds. And where is everybody today? I have 3 more people. So before we go today, I'll have you, I already know several people who already typed in their names, but if you didn't type in your name in chat, just type it in. All right, so let me just go back to our ionic compounds. So remember how we named them? To put it together, you had your cation name first, and then your anion name, right? So when you had something like, let's do something like that. Then we say, oh, metal, non-metal, ionic compound. The metal is my cation. Okay. My non-metal is my anion. Oxygen is group 6A. So I know the charge on the anions is -2. To make it neutral, then this must be a +2. Okay, remember this is a transition metal, so I have to write down my charge. So it's going to be titanium 2, right? My cation name is going to be titanium 2 ion. My anion is oxide ion, and all we have to do is drop the ion. So the name of that compound is titanium oxide. And it goes back, if you know your cation and anion names, you just put them together. So when we have polyatomic ions, like this, okay? Whenever you have more than one polyatomic ion, you put parentheses around it and you put the number of those groups on the outside. If you only have one, you just write down your polyatomic ion. Okay, no parentheses. All right. Now you have to then be aware the reason that you really need to know all of your polyatomic ions is you see the PO4, you have to recognize it and know, oh, that's a phosphate. And you don't need to like, is it a phosphorus tetraoxide? No, it's not. Okay. So then when we look at this, you have to have memorized. This is what the charge is for that one. And this is what the charge is for the phosphate. Okay. So that's how you can get your formula. But now you know this is my ammonium. And this is my phosphate ion. So the name of this will just be ammonium phosphate. Just your cation name, anion name. We don't need to write the charges on ammonium. We have that memorized. Okay. What happens if I give you okay, metal, group of nonmetals, you know it's an ionic compound. What would you name this? You want to see the table of ionic or polyatomic ions? Okay, have this written down and let me just share that. Then you can see your list of polyatomic ions there. Okay. So tell me when you want me to scroll up. I'll try to blow this up a little so it's easier to read. How's that? Is that good? Okay.
Professor, where do I get this list?
It should have been on the chat last time, and if you don't have it, then I'll go ahead and put that on Canvas in the announcement, okay? And the module. And Victor, almost. I agree with the acetate. What do you know about your mercury? Is it transition metal? And if it is, you need to write the charge. So what's the charge on your mercury? Beautiful, right? See, is it mercury 2 or is it mercury 1? Let's go back to what I drew, okay? Yes, Melissa, it's mercury 1. So we'll go back to what I drew. And Jose, let me go ahead and I'll, where to go? I'll attach it again to the chat, but I'll put it into announcement too, okay?
Thank you.
So see how it's mercury 1? Yeah, no worries. So when people get into a rush and they see the subscript 2, they put that down as a Roman numeral. And so it's like, no, it's not your Roman numerals. It's not how many you have. It's your charge. But this is actually mercury 1 acetate. Isn't that great? Okay, so I'm going to launch this poll. And while you guys are answering this poll, I'm going to post up that file in chat. Okay. Oh, here, I better close it first. Okay, you should see it in your chat box, so you should be able to download it from there. Okay. And one more, or am I the? Goodness. Okay. Is molybdenum a transition metal or a main group metal? It's a transition. Is it zinc or silver? I know it sounds like a silly question, but is it zinc or silver? It's not either, right? So if it's a transition metal and it's not zinc or silver, then you have to write the charge. Okay. And then N, is that a neutral atom or is it an anion? So what does N stand for? What's the element name? Exactly. And it's an anion, right? So what would you call it if it's an anion? So you know it's molybdenum. You know you have a nitride. What's the charge on the molybdenum?
One.
No, if nitride is a -3, because look at what column is it in? It's in 3 minus, or it's in 5A, right? So 5 minus 8 is -3. So if nitride is a -3, then molybdenum has to be a +3 to make it neutral. You see that? So nitride looks like this.
No, so you were looking at the periodic table to get that?
Yes,
Okay.
because remember, your anions won't have multiple charges, so we can look it up. Okay, molybdenum, we don't know what it is, but you know that the sum of the charges has to equal 0. So the molybdenum must have a +3 charge. Okay. And since it's a transition metal, we know we have to write the charge. So that's why it's molybdenum 3 nitride. Okay. Because if you said molybdenum nitride, then I won't know whether it's 2 or 3. Okay. So far, so good. Okay, so let me go ahead and do this. I'm going to give you some names, write it down, and then what I'm going to do is I'm going to show that table with your polyatomic ions again. So I want the formula for ammonium oxalate, chromium 3, say permanganate. Ooh, that's a fun one. How about acid? And I like the formulas for these, okay? So let's have these written down so I can share the polyatomic ion table. Oh, you have that now too. So that's good. Let me go ahead and share that. And then we'll go on to acids after this. Okay. All right. So I think the more important one is for you to see your polyatomic table. So we'll start here. So, and the ones that you're looking for, wish I could just split the screen. Is there a way to split these screens so you can see both what I wrote on the whiteboard and your polyatomic table? No, yes. Let's see if I can do this. Okay, so here we go. I'm going to try something. I hope it works, okay? So let's try. All right, if I say share, hold on. Share screen 1. Okay, can you see both of them side by side, more or less? Let me just
Yes.
okay, let me scooch this over. Sorry. I get the ions to learn. That's good. And my whiteboard. Where's my whiteboard? Where'd my whiteboard go? Okay, hold on. I get my whiteboard back up. Sorry about that. Okay. Well, that didn't help because you needed to see the whiteboard too. I hope you can see both. You can see the whiteboard, right? So ammonium oxalate. There is no whiteboard. Oh, okay. So ammonium oxalate. What does ammonium look like? Thanks, Victor. I was hoping I could show you the whiteboard and this at the same time. That would have made life so much easier. Okay. Oh. See, while I'm goofing off trying to get this to work, someone's been working. Ammonium is NH4 plus, and oxalate is C2O4 2 minus. So I need 2 of these in order to make it neutral. Okay, so oxalate looks like this. And ammonium ion looks like this. So I need 2 ammonium ions for every one oxalate. Okay, what about chromium 3 permanganate? Do you know what permanganate looks like? Do you want me to show you that list, or am I giving you a headache bouncing back and forth? Okay, so permanganate is MnO4 minus. Chromium 3 is Cr3 plus. So you have your chromium, you have your permanganate, but I just need 3 of these. Yeah, use chromium 2. Okay, beautiful. All right, last one, barium acetate. So what does acetate look like? I showed you really quickly. You got to know this one, right? Acetate is C2H3O2 minus. What does my barium ion look like? What's the barium ion look like? It's barium 2 plus because it's an alkaline earth metal. It's in column 2A. So I have 2 acetates. This is polyatomic, so I need to put those in parentheses and then put the 2 on the outside. Nice. Very nice. Okay, so far so good? How do you guys feel? Suddenly now you have a lot to memorize, right? Let me give you a few with the names and then we have to move on to the acids. Okay, so give me the formula. Let's see, you were giving me the formula. Let's give me the names for. And I'm going to give you anything I think of. How's that sound? Yeah, that'll be good. Can do this one now. Oh, we can do, we can do that one. We can do this one. We can do this one. We can do. Oh, I have many more to choose from now. This is nice. Oh, we haven't done this for a while. Let's do oh my goodness, I'm missing a couple more. Let's do and let's do, that'll be good. Okay. So let's name away. What would you call the first one? And let me know if you want me to put the table back up so you can see the polyatomic table. So if you're wondering what to do, the first thing you're going to answer is this question. Is it an ionic compound or is it a molecular compound? What do you think it is? Ionic or molecular? Guys still there? Let's take a look. Is sodium a metal or a non-metal? And hydrogen and carbon and oxygen. Well, this is going to be a polyatomic ion, right? So this is your non-metals. So if you have metal with non-metals, is that ionic or molecular? Almost. So metal with nonmetals. Sorry, Victor, I'm going to slow you down for a second. Metal with nonmetals, it's ionic, right? Because it's metal, nonmetal. If it's ionic, then the naming is you have to name your cation followed by your anion. And that's it. So sodium is my cation. And my anion is not carbonate, but carbonate. Hydrogen carbonate is the name of your anion. Okay. So that's what you would call it. Okay. What about the next one? The first thing you're going to ask yourself, is it ionic or molecular? And if it's metal with non-metal, then you can say, oh, I think it's ionic. If it's only non-metals, you say, oh, I think it's molecular. Because if you use that, then you'll know which naming rules you're going to follow. So this one's ionic. So again, we're going to do cation, anion. So what's my cation? Cesium. What's my anion? Oxygen. So because it's my anion, you're going to take the base name, right, of your element, and then you're going to end in I. Now, is cesium a main group metal or a transition metal? Main, so I don't need to write the charge, right? It's not letter 10 either, so I don't need to write the charge. So we're done, cesium oxide. Okay, what about the next one? Ionic or molecular? What do you think? Ionic or molecular? You guys are so quiet. Is my internet working? Ionic. Okay, thank you. So cation, anion, right? So what's my cation? Lead. Okay. Now the question I have for you, oh, we'll just do this after. What's my anion? Dichromate. Okay. Now, if you look at your anion, dichromate, the charge on the dichromate is what? 2 minus. Okay. So that's something you're going to have to just memorize and then you get used to it. So now, what is the charge on my lead? But lead is 4 plus, the total for dichromate is 4 minus. Now, here's the question I have. Do I need to write the charge down? Lead is in group 4A. Is it one of those exceptions? Do I need to write the charge? Yes? No. And the answer is you guys flipping a coin? You guys know. Should I write the charge? Or should I leave it blank like cesium? I'd say yes, I agree. Yes, Melissa, yes, Victor. Lead and tin, even though they're in 4A, we need to write the charge. Beautiful. Yes. Okay, let's do one more and then we'll switch over to acid. I mean, inorganic acids. That's much fun. Okay, what about this one right here? Ionic or molecular? Who else is here? You guys are making Melissa and Victor do all the work. All right, Loretta, you're still here. I know that. Ionic or molecular? Molecular. Beautiful. Beautiful, beautiful. If it's molecular, then we're going to use the molecular naming rules. So what would you call it? What's my first element? Xenon, beautiful. And then what about my second element? What do we write down? Is it fluorine? What do you end in? Ide. Like beware the Ides of March. So xenon difluoride. Beautiful. Okay, what's this top one called? Do you know? Yes. It's just your element. I don't have two or more. Nice. Okay, so I'm going to clear the screen. You can name those other two for me at your leisure. All right. Now, remember we talked about common names. So you should know the common names for these molecules. The top one is called, yes. We don't call it dihydrogen monoxide. And the second one is called ammonia. Yep, exactly. Okay. So ammonium ion. So the difference, of course, is this is NH3, this is NH4 plus. The NH4 plus is ammonium. So notice the difference. Okay. Now, we also talked about these common names, this ic and this s. Okay. And when you look at your polyatomic table, you'll see acetate. Let me just give you one that has a set. Okay. So this is sulfate. This is sulfite, SO3. What am I doing here? So when you look at your polyatomic tables, you're going to see things that end in 8 versus ite. And the only difference when you look at 8s and ites is ites have 1 oxygen less than 8. Okay, everything else, charge stays the same. All right, now why did I bring up ferrous and ferric? Remember, ferrous is 1 charge less than ferric. So you're going to name this one before we move on to your acids, because this part you do need to know when we start naming our acids. Okay, and I'll go through that list again with you. But what you need to name for me right now is this compound. And if you're going to say something like, oh my goodness, it looks so complex, do you know how to name it? And my answer to you is absolutely. So do you know what this is called? It's a Ferris wheel. You guys never go to the fair. Where's the gales of laughter? You know, Ferris wheel. Okay, thank you. You thought I was really serious. I wanted to make sure that you didn't get thrown off. You probably took this all down as notes too. Okay. Isn't that great? Every once in a while, I can still throw out a bad joke and get you guys. Okay. What's an acid? An acid is that when it's dissolved in water, produces hydrogen ion. Okay. So we can say it's a hydrogen ion donor in water. Ah, yeah. Sorry. Okay, so acids donate hydrogen ions in water. That's why we call it pH when you're looking for acidity. You're looking at the concentration of hydrogen ion. When we draw the formula for an acid, we put our cation and our anion. Okay, so the H plus tends to be in the front. Okay, so cation, anion. So one of the things about acids is we need to make sure they are charge neutral, just like an ionic compound, even though there's no metal cations. The cation is H plus, a single plus, okay? So when we look at our acids, there are two types. We have what we call binary acids, and we have oxyacids. Okay, so with the binary acids, it's just two binary for two elements. Okay, one being H and one being some other element. Okay, when they are not in solution, when it's not aqueous, we use the molecular naming. Okay, so for the binary acids in particular, we have to write aqueous in order to do the acid naming. Okay, so when we have this, the way we name it is you use hydro, okay, plus the base name of my element, and plus ic, and then acid. Okay, so here, this is the longest way to explain that this is called hydrochloric acid. Okay, if I give you this formula, what would you name it? Yes, hydrofluoric acid. Perfect. What would you write if I gave you this for name? Hydrosulfuric acid.
HS.
Now, when you look at sulfide, what is the charge on a sulfide anion? So if you look at your periodic table, what column is it in? Sulfur is in column, it's right underneath oxygen, right? So it's 2 minus. And since we know it's an acid, this is hydrogen ion, it's a plus. So how many hydrogens will I need? 2. So Jose, you're right. You just needed to make sure it was charge neutral. So H2S. But notice, because of this prefix hydro, it's not sulfuric acid, which has a completely different formula. It's hydrosulfuric acid, which means we need to write aqueous after it and write H2S. It's just a binary acid. Okay. So let me start introducing you to your oxyacids. Are there any questions on binary acids? We don't have too many. Oxyacids, we have a lot. So for oxyacids, what does that mean? So if you look at the general form for an oxyacid, you're going to have some number of hydrogens for your acid. You're going to have some element. You're going to have some oxygens. Okay. And what happens is when we look at our oxyanions, okay, oxyanions just contain an element and oxygens that has some charge. So let's take a look at that table. So when you look at the table, you're going to have a series of 2, and you can have a series of 4. So let's work on the series of 2 first. If this is called nitrite, now how do we know this is nitrite? So nitrogen is part of this oxyanion. So this part tells you I have nitrogen as part of it. The I tells you I have 1 less than 8. Doesn't tell you the charge. So that's why there's all this memorization. So nitrite is NO2 minus. What do you know about NO3 minus? What do you think that one's called? It's not nitrite, it's going to be nitrate. Beautiful. Okay. So in your series of 2, it has 1 oxygen less than 8. So what's a little bit, that one's not so bad. Let me do, yeah, we'll just keep this one. So if I gave you this series and I said, oh, this is phosphate, then what do you think this one's called? PO3 3 minus. Beautiful. Phosphite. Okay. The thing is, you're still going to have to memorize it because it doesn't tell you the charge. You just know phosphite has 1 oxygen less. Now let's take a look at a series of 4. So we'll do the series of 4 tend to be only your halogens with chlorine, bromine, iodine. We don't typically see it too much with the other elements. Okay, so this will occur with chlorine, bromine, iodine. If this is chlorite, then what is ClO3 minus? Chlorate. Now what happens is if I still have another oxygen, what do? So to go from ClO3 minus to ClO4 minus, I don't change the ending, I add something here. This is per chlorate. So the per tells you I have 1 more oxygen than chlorate. Okay. What about ClO minus? I have 1 less than chlorite, so it's hypo. That's 1 less than chloride. Okay, so what happens is the inner 2, you still have your chlorite and chlorate, and then the outer 2, you need to put a prefix. Now remember, hypo is not hydro. So hypo, once you know your anion, that's the name of it, hypochlorite. Okay, now all of this is important. This will help you memorize your tables of polyatomic ions, but what does this have to do with your acids? Well, it turns out when you have an oxyacid, So it's not binary, right? Here you have 3 elements. Okay. If you end in 8, if your anion ends in 8, then the acid, it goes to ic acid. Someone told me once they learned it by saying, I ate something icky. If your anion ends in ite, then the name of your acid goes to us acid. Okay. Now there are only a couple places where you're going to see us add a few more letters. Sulfate goes to sulfuric acid just because it sounds better. Phosphate goes to phosphoric acid. So we just re-put in the OR and the UR kind of aspects. Okay, so let's take a look at those. We'll do nitrite and nitrate first, and then we'll do the other ones here. Okay. So if you have an acid that looks like this, and what's interesting is with oxy acids, even though we know we want them aqueous, we don't have to write it down because the naming stays the same. It doesn't change. All right, if it's aqueous or not. So this one, see that? That's nitrite. This tells me I have an acid, right? Because the hydrogen ions on the front. So we call this nitrite goes to us. So this is nitrous acid. Okay. And the nice part is acid will always be in the name of an acid. So I say, oh, look it, is this an acid? And you say, oh, it's nitrous acid. The answer is yes. Okay, it's in the name. So here, what would you call this acid? Nitric acid. Yep. Perfect. Okay, so let's do a few more. And then, did I ever tell you why chemists tend to like nitrate a lot? Do you know why? Turns out nitrates are cheaper than day rates. Nitrates. You guys don't stay in hotels either, huh? Nitrates are cheaper than day rates. Please don't drink it with vodka, but okay. Oh my goodness. You guys are a tough crowd today. What am I going to do? Finish naming. I got to become serious. We are now being serious. Name the following acids. I know. Did my bad jokes chase you guys away? Oh no, that also means I won't get much of a tip today, huh? All right. How would you name this first one?
But we're the best group.
I love it. Okay, name my acid. I can name that acid in one note. Well, almost. This is hypochlorite. Yeah? Yes, hypochlorous acid. That's okay. I don't even have to do a typo. I can just misspell everything as I'm writing. What would you call this one then? What about my second one? Yes, beautiful. What would you call my third one? Yes. Oh, you guys are on a roll. And the last one, yes. There's no A in there. Oops, now I'm writing the A, sorry. That was a typo just per chloric acid. Yes. Yes, yes, yes. This is great. Okay. It's okay. All right. So we just finished all the naming that you need to know, except for hydrates, but we'll do hydrates next time. Now I'm going to do one other thing. Okay. Just to give you a heads up on how to do it. Okay. Share screen. Where'd I go? All right. So these are your naming sheets. And I just wanted to quickly go through, not naming all of it with you, but just what's expected out of it. Okay. So when you fill out this table is tiny, tiny, tiny. So it's going to be hard to fill everything in. Do your best, or what I highly recommend is just doing it on a second piece of paper, okay? Because it just makes life easier. But this is what they want you to do. You're going to write, these are all your anions on the top row, hydroxide, nitrate. So you're going to put in the formula for your anion and the charge, cyanide, carbonate, okay, sulfide, sulfate, phosphate. Okay, and use that table that I gave you to help you fill that in. In your first column, these are all your cations, okay? So you want to put in your formula for your cation. So hydrogen ion looks like this. Sodium ion looks like this. So it's not the element, but your cations. Ammonium, you know, it looks like this. Calcium ion. Iron 2. Okay. And then I'll stop there for now. So the hardest one to fill in this table will be the first row right here. Okay. So just so you're aware. So I'll do that with you. Let me show you we're going to do it in a different order. I'm going to show you this row first of what you need to do. And then I'll show you the first row, because the first row has so many exceptions. But the second row, I want to show you what the trend is. So let's do that one first. Okay. So what you're going to do is you're going to make your compound and make sure it's charge neutral. So you're going to write the formula, NaCl. Okay, that's charge neutral. And then you're going to write the name, and it's cation name, anion name. Okay, and you can already see I'm running out of space. All right, NaOH. And then you're going to write cation name, anion name. Okay, when you do your third compound, NaNO3, charge neutral, what is that called? What's my cation name? What's my anion name? Yeah, sodium nitrate, beautiful. Okay. When you get to your compounds that are but like a -2, how many sodium ions do I need to make it charge neutral? I need 2 of them, right? Because this is a +1 and that's a -2. So make sure you put the appropriate number to make it charge neutral. And then again, cation name, anion name. Okay, so your whole goal is to make sure it's charge neutral. Okay, so far so good. So basically, once you do that, then everything else down after sodium ion, you're going to be doing the same thing. Okay, so what's the problem with the first one? It's not really a problem actually, but we have a lot of exceptions. So let's take a look at what these exceptions are. This is HCl. Okay, we're going to assume it's aqueous. So this is not hydrogen chloride. This is hydrochloric acid. Okay, so sadly it's not cation name, anion name. What about HOH? What is that? It's H2O. This is water. So you're not following the cation name, anion name that you would starting with the sodium. Okay, this one, now we're looking at acids. This one, this is just hydrogen cyanide. So in this case, it's cation, anion, but this is an acid. This is going to end in acid. This one is also going to end as an acid. So you're going to look up the name. This is a carbonate. So that if it's an acid, then what kind of, how would you name the acid? And then we did this already. Okay, it's binary. So you're going to need to write aqueous. This one with sulfate, what's it going to be called now? This is an acid. We have to put 2 hydrogens to make sure it's charge neutral. But what would you call this acid? 8 goes to you could say it. You already did a lab on it too, as far as I remember. For experimental, you did all this work researching it, right? This is your sulfide, this is your sulfate, right? So what was the acid you did all that research on in experiment 1? You even rewrote the label. Remember you had to do all that work with a safety data sheet and rewrite labels. When you're looking at this old label that no one can read, what was that acid?
Sulfuric?
Yes, this is called sulfuric acid. Okay. And so from the sulfate, instead of saying sulfic acid, we add the sulfuric, make it sound a little better. So this one, when you make it charge neutral, it's phosphate, so it goes to what kind of acid? Eight went to ick, right? So 8 goes to, what would you call that acid? It's in my Diet Coke too. They put in my Diet Coke. Put it in regular Coke too. What's this last one called? Phosphoric acid, which I'm going to be drinking once I'm done with lecture now. Okay, so except for row 1, where you have all these acids and you have some common names. You also have the cation name, anion name here, hydrogen cyanide. Everything else is an acid. Once you finish row 1, which we almost finished completing here, row 2 and on is just cation name, anion name, because we're looking at just ionic compounds. They're not acids, okay? And so you'll just write the formulas and put in the name. And if you run out of space, instead, you can just write the formulas, and on a second sheet, just write down what their names are. But make sure you complete it so you have all your names done. And then this is more practice for naming and getting formulas, right? So formulas and for naming, okay? So I just wanted to go through that first row with you, because in particular, that first row has all these exceptions in it. And so once you get to row 2 and beyond, then it's like, oh my goodness, naming is actually a lot of fun. Okay, so I'm going to stop here. And do you guys have any questions? That's it. We finished all the naming except for hydrates. We'll do hydrates next week. You guys are going to have a really good day. And I will finish all your exams by the end of today. Yeah, what's going on with the exam?
Yeah, so I just wanted to ask, I know for question 8, what was supposed to be the right answer? Or I was just kind of confused.
Oh, are you talking about the 8 that had no answers on there?
No, which is a scientific observation.
Oh, that was mercury is a liquid. That's an observation.
Because that was marked as incorrect.
Yeah, I think
Oh,
I
but
should.
it's right. Okay. I see the
Right,
point
didn't I
now.
change it? Because I've been going through and looking at all the questions and making sure. So what happens is this: if it's marked incorrect, I read it and decide if I want to change that grading or not.
Yeah, it makes sense now. I was confused because it still has the big red in your face incorrect, but it has 2 out of 2 points now.
Yes, it should.
Okay. Yeah, sorry about that. Thank you.
No, that's okay. I looked just like, oh my God. I'm so mad at myself. It's like I wrote so many questions. I think percentage wise, it's not bad, but it's just really frustrating because I don't like doing that to you guys. So yeah, I regraded it. So everyone who wrote that it was mercury as a liquid would get full credit.
Okay.
Okay. All right, everyone. Have a good weekend.
Thank you, Professor. You too. See you